the missions, the table layout, and the constraints. For the missions, we studied the mission thoroughly so we could make really good attachments. And for the table layout, we noticed there were a lot of black lines. So we added 2 color sensors so the robot can follow the black line. And for the constraints were time and the inspection area. For the inspection area, we decided to make a robot really small, so we would get the points. And like this, we had a lot of requirements for our good robot. So when we researched online for a good design, we came up with the box robot because it fit all of our requirements.
Our robot has two tires in the back and 2 rollers in the front. We chose medium tires because they have a good balance between speed and precision. We also had a problem with tire camber, but we fixed that with adding supports to both sides of the robot.
Choosing motors was very simple. We had 2 large motors to spin our wheels and 2 medium motors to spin our attachment mechanism. Based off of what Yash said, we also have 2 color sensors in the front corners of our robot to help us align with black lines and roll across them. And we also have a gyroscope sensor here to help us turn more precisely. To decide which missions we were going to do, we created a mission matrix. The criteria for the mission matrix was distance, complexity, and points. The bench had one of the highest scores, so we decided to do it. And the tire flip had one of the lowest scores over here, so we decided not to do it. On our robot, we have these doggy gears, which are supposed to use for attachments. For example, the bench goes under the pull-up bar and then dumps the cubes using these dog gears, which are powered by these medium motors and are which move the gear mechanism. This is the attachment that moves the innovation project and the 3 health units to the gray area around the bench. This attachment lifts the backrest off the bench, and when this lever is activated, it dumps the cubes into the hopscotch area. Our coding strategy was very modular, so we used a lot of my blocks. One of the my blocks we used was to follow the black line. Here's an example. So the robot just won't go anywhere. It'll follow the black line and then stop at the black line when it's going to do a mission. Another example here is the men's mission code, dropping the cubes in. So this part of the code is moving forward to the bench. This part of the code is lifting the backrest off the bench, and this part of the code is importing the cubes into the spaces. One of the hardships we faced was COVID. Because of COVID, we were supposed to be a large team, but then we're split up. So we had to create 2 robots hybrid. So this robot was the one that proceeded, and that's it.